let's learn about recursion in Java. Recursive method calls is something that we rarely use in Java, but learning about it is really critical. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. Today, we will learn how we can recursively call a method and cause a loop until a certain point so that we get a method call that happens time and time again, and it is calling itself until a very special condition is met. This is called recursion. Basically, in recursion, a method will call itself. This may sound confusing at start, but when you learn about it, it's really a simple concept, yet very powerful and very dangerous concept. Okay, let's start with creating our method first. So public static returns integer. We call it sum. We accept an integer. We call it k. And the base concept of recursion is that at some point inside this method call, we call ourselves with some number. This is called recursion. Basically, the method is being executed, and during the execution, it is calling another execution of himself. To take a look and find the result of something like this, we will say int result equals to, this is the very first call of this method. And we say system.out.println result. Basically, when the program is running for the very first time, it will call this sum, and this is the first call of this method. Now, within this method, we will say if the k that we sent in is greater than 0, we want to return the k plus sum of k minus 1. Else, just return 0. If you look at this code and if we execute it, we simply get a result as 55. That's the sum of numbers between 0 to 10. So it's 0 plus 1 plus 2 plus 3 plus 4 plus 5, 6, 7, 8, 9, and 10. You can sum it up and you will see that it becomes 55. However, the program is not being executed in this way because we are sending in 10. Let's follow the logic here. 10 greater than 0, yes. So we want to have 10 plus something. So the execution will be 10 plus sum of, when we are getting here, we reduce 1 from this number, so we'll become 9. And we are calling ourselves with the 9 here. Okay, the second iteration is 9 plus sum of 8. And the result of this is going back to be applied to the 10 because this is the sum of 9 basically. The next iteration we have 10 plus 9 plus. Now this sum will become 8 plus sum of 7. The next one will become 7 plus sum of 6. The next one will become 6 plus sum of 5. The next iteration will become 5 plus sum of 4. The next iteration, 4 plus sum of 3. Next one will be 3 plus sum of 2. 2 plus sum of 1. 1 plus sum of 0. And as you see, we are still looping through this whole scenario until we get here. Because we are checking if the k is greater than 0, then do the recursion. If the k becomes 0, then we break out of this recursion and we go back. So the last iteration actually will be 0. And finally, the program understands that, okay, I don't have the recursion anymore. So let's go back from here toward the left and return everything to the previous call, to the previous call, to the previous call, until we get here. And then we have the whole summary. So we got here at the top, and the result will be 55, and it will be printed out. This is called recursion, and this is recursive calling ourselves. What if I didn't have this condition. What do you think will happen? Let's take a look. Let's execute it, and we get a bunch of errors. As you notice, it's a very big list of errors being printed out, and all of them are almost the same. And it says Java lang stack overflow error at main.java line 13, and that is here. When you see stack overflow, it means that I tried to execute your command, but for some reason I fell into an infinite loop and I got to the situation that the memory was not sufficient to continue the loop. And if we want to take a look at these errors to see how long they are, I just copied the at main sum repetitive code, and here I will say new, let's say file, and make it r.txt, whatever, and just paste. Now you see that we tried to run this command for 1024 times. And after that, we got to the situation that the compiler understood, or the program understood, that, hey, we are not getting out of this loop at all. And we are still trying to continue to call ourselves. So we have a stack that is growing and overflowing of this growth. And that is the stack overflow error for you. Basically, when you are doing recursion, make sure that you have a condition that will take you out of this recursive call. This is exactly like a while loop. However, here we are doing more complex logic. We are not just looping through a number, a counter, or a situation. We are calling ourselves to get a result of some complex logic back. Where can I use recursive calls correctly? For example, let's say that we are developing a game program. And in game programs, when we are working with humanoid characters, we have bones, and these bones are being added into a hierarchy, and we have 5 fingers, for example, here, and each finger will have 2 more joints. Okay, this is a very rudimentary example here. This was head, neck, and this is upper chest. This will be shoulder, elbow, wrist, and fingers. Then we will have a hip, or maybe a middle back, and then the hip, and then we go for thigh, knee, etc. So if I choose this bone in the logic of the game, and I want to get all the bones that are children of this guy being listed, and let's say that the software is not providing a method call for that. How can I do this? I can say for each child of this bone, add the child to the list, and then look forward. Again, for the child of this bone, go find the children. For the child of this bone, go find the children. And again, when we added this one and this one to the list and made sure that the parent has no more children, then we recursively call for finding the children of these guys and adding them to the list. Then we made sure that these two are not having any more children. Now we have 3 more things to recursively call and find their children. And well, this one has no children, it is finished. This one had one added to the list. This one had one added to the list. Now it's time for this guy to look recursively and this guy to look recursively. This does not have any children, so the loop for this guy is finished, but the elbow has the children, and so on and so forth. We go forward level by level, add the children level by level, and then recursively call ourselves on those children to find their children until we get to the end of each one of these branches and we make sure that we found something that has no children. And remember, during this whole process, we have a global list somewhere being cached in memory, and we are adding each one of these findings into the list. So when we get to the end of every branch recursively, now we make sure that we have all the children being listed inside the list. And now the program recursively comes back out from all branches to the main object that we had, and it will output the result. This is one practical example of calling recursion on a method related to games, of course. The other example would be the node-based editors inside different game engines. In Minecraft, however, there can be one critical situation. We all played Minecraft and we all saw that we can have machines, and some mods are adding cables. Cables are pieces of blocks that being connected to each other, isn't it? The fun part of using cables in Minecraft is that they can branch off. Now, let's say that we want to send energy out of this generator toward the whole network and every machine that should receive the energy. How can we find these machines? How can we balance the energy in the cables and in the machines? All we have is this piece of cable block. And the same logic about the bones and humanid character applies here. This will recursively look for own children finding this. This will recursively look and find this piece of cable. This will recursively look and find this and this cable, and so on and so forth. The command will recursively look for every children inside the nodes. Finally, when they see entities, block entities that receive power, they know that they can find the machines, and this branch is finished, this branch is finished, the whole list will come back outside of the recursion. Now, this machine finally knows the result of every search, and it can find its own network of cables and transfer the energy out to the network, and each part of network now knows what to do. So this recursive call has practical examples in these sort of situations. Complex logic that needs to be repeated on itself and children. That's the best way to describe it. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.